So the goal of this video will be to correct and go over the calculating dilutions problems. And it's important to note that every scenario is in fact fictitious. It's just meant to provide us with some mathematical practice to make sure we understand what we're doing. So before we begin, the dilution formula that we are learning and using is the following. So the initial concentration times the initial volume is equal to the final concentration times the final volume. We need to remember a couple of facts. This part of the equation deals with your concentrated solution. Okay, this part of the equation deals with your diluted solution. So because of this, there are some facts. Your first concentration, or C1, is always going to be greater than your C2. And your initial volume is always going to be less than your final volume. Because since you are creating a diluted solution, you have to add more solvent, and solvent corresponds to quantity of water, therefore volume. Now, it doesn't necessarily have to be water, but in the examples that we're using here, we are dealing with liquids, primarily water. So we begin, and the way in which we should begin is we read the question and then highlight or circle some of the numerical information and underline the question. And then from there, work our way around placing them in the correct location to try and determine what in fact we are solving for. So a lab technician has a flask of 3 grams per liter of glucose solution already prepared. She needs to prepare 450 milliliters of a 1.2 grams per liter glucose solution. What volume of concentrate should she use? So in this example, we always, of course, need to start by writing the formula, and getting to write the formula makes sure that when we set up our math, we are going to set it up in a proper way. Then we also have to indicate what our variables are. Okay, so now that that is ready to go, we're going to start to place anything at this point, whatever sort of stands out to you. So there's many ways in which we can do this. So for example, what volume of concentrate should she use? There are some key vocabulary words in this. Volume deals with V. Okay, so concentrate indicates you're talking about the part of this scenario whereby it is highly concentrated. This indicates that we are going to be solving for V1. So V1 is our X. Given this, we're going to place the remaining variables. And according to our rules, which of these two concentrations are in fact greater? Once we determine which one is greater, we know that that corresponds to C1. So 3 grams per liter is greater, therefore it goes at our C1 position, and 1.2 grams per liter is the less greater one, if that makes sense, goes to our C2 position. Then, because she's preparing a solution that has a quantity of 450 milliliters, we are going to be placing 450 milliliters here. Now, we know that as long as our units are consistent, which means if concentration is in grams per liter and your second concentration is also in grams per liter, those units are consistent with each other, we're good to go. For volume, if the volume unit is in milliliters, we know that by default, once we solve our V1 answer, the unit will also be in milliliters. So there's no conversion necessary at all. We just have to make sure that the units are consistent. Now that they are, we can set it up. So according to the formula, we're going to set it up as follows, and we're going to make sure that we're not going to indicate the units inside our formula simply because we don't want to cause congestion in the area. So according to this, we have 3 grams per liter, which is our first concentration, times X, which is our unknown, is equal to 1.2 grams per liter times 450 milliliters. So I like to break this down one step at a time. And in order to do that, I'm going to walk you through the math to make sure that this makes sense. So having said this, we have 3x because 3 times x is equal to the product of this. And that product, after we use our calculators, is 540. At that point, we would like to isolate our variable. So in order to do so, we have to bring this 3 over to the other side because we want to leave the x alone. And since the 3 is multiplying the x, it's going to do the opposite when we bring it over to the other side. So x, therefore, is equal to 540 divided by 3. And once we figure that out, we're actually going to end up with our answer. And that equals to 180 milliliters. It's always a good idea to highlight, put a box or circle your answer so that way it is visible to the person who's grading your work. And therefore, we solved our first equation. So what does this actually mean scientifically? It means that when this lab technician is going to create a diluted solution of 1.2 grams per liter in 450 milliliters, they are going to remove 180 milliliters from the original concentrated solution, put it in a separate container, likely a flask, and then, of course, add the remaining water in order to dilute it. Okay? Perfect. So now we're going to do the same thing for the second question. We're going to read the question and go through what it is that we need to solve for. So to dilute 4 liters of a solution that has a concentration of 32 grams per liter to a solution that only has a concentration of 14 grams per liter, the question is, how much water must be added? Now, it is important that when we see how much water must be added, we know that this particular question is actually going to be a 2-part problem, and we're going to show why. So first things first, we always start by writing our formula, so that way we stay focused on the task at hand. We prepare a location to identify our variables, C1V1, C2V2, and we proceed to solve. Now, how much water must be added means that we're dealing with the second volume, because obviously we're adding more water, which means we're dealing with the diluted part of this particular question. So therefore, V2 will be our x. Given that, we can now place the remaining variables. And of course, we're going to go by the clues. 32 grams per liter is greater than 14 grams per liter, which means 32 grams per liter is our C1. 14 grams per liter is our C2. And that means that V1 is 4 liters. We know that because V1 is in liters, our X, once we solve it, will also be in liters. And then we proceed. So 32 times 4 is equal to 14 times X. Therefore, we're going to break it down one part at a time. And what this actually ends up being on this side is 128 is equal to 14x. In order to isolate the x, I want to bring this guy over to the other side. And I'm going to do the opposite of what he's doing here. So 128 rather, divided by 14 will actually give us our answer. So x then is equal to, and it's always good to round to 2 decimal places, that's sufficient, 9.14 liters. Now, this corresponds to the actual volume of the entire diluted solution, but we want to know how much water was added. So we have to do a second step. We take the final volume minus the first volume, and we actually get our answer. So in this case, the final volume is 1.4. The first volume was 4, which means that we are only going to have to add 5.14 liters to the already existing 4 liters, and therefore this is the answer. 5.14 liters is how much water we need to add to the original solution.